So this is my home. It's located in northern New York State. Our heating degree day is around 7,600 and cooling degree day around 350 degrees Fahrenheit. The house is around 50 feet long by 26 feet wide, making for 1,300 square feet per floor. We have a finished basement and first floor living space, totaling around 2,600 square feet. Total wall area comes to around 2,280 square feet, of which around 10% is window. Doors account for around 3% of wall area. Insulation. Wall insulation is R13 fiberglass, plus we have around a ½ inch of R5 per inch foam board under the siding outside. Ceiling insulation around R21 fiberglass, plus 3 inches of cellulose totaling R9. Windows. We have a typical double-paned window, although they're pretty old and some of the wood frames are warped. 11 are wood framed, 7 plastic framed. Here are some of the windows around the house. Doors. There's 3 doors leading outside. All are insulated metal doors around R15. Here are some of those. As you can see, all have storm doors. Heating systems. We have 2 heating systems, a wood stove and an oil and a wood furnace, although we only use the oil on the furnace. The wood stove we use around 10 cords per year at 65% efficiency, and it pumps out around 30,800 BTUs per hour. We use around 130 gallons of heating oil per year, and that works at around 80% efficiency to bring 168,000 BTU per hour. Here's a picture of the wood stove, and then here's the furnace. It's quite large because it's both wood and oil. The wood stove, effectively we get around 1.3 times 10 to the 8 BTU per year. The furnace gives us around 1.4 times 10 to the 7 BTU per year. Now, as you can see, using wood as a heating fuel in my area is pretty common. Around 33% of homes use it as their primary heat source. So let's take a look at the way that heat flows from the heat sources around the house. So here's the wood stove and here's the furnace, both in the basement. I'll draw the furnace where it would be on the first floor. Here are some fresh air ducts feeding the furnace from the first floor down to the basement, and the heat would go into the furnace, travels through these ducts that you see here, and then travels out through the ducts to the different rooms in the basement, and along the same system to the rooms on the first floor through floor heating, through floor air vents. And if we then take a look at the way that heat flows out of the house, you get some flow out of the concrete through the basement, although there is some insulation, foam insulation around that. You get heat flow out of the windows, out of the doors, out of the walls, and up through the ceiling of the first floor into the attic, where it can then flow out of the vents and along the vents at the peak or the soffits. Improvements that could be made. Replacing the older warped wooden framed windows, some of those have pretty substantial air leaks. You can have better wall insulation, you can seal the gaps in the wall as there's currently high infiltration, more efficient furnace, more efficient wood stove. You could also have a better heat distribution from the wood stove as it really only heats part of the downstairs. Now if you take a look at the energy intensity of my house, we use around 9,500 kilowatt hours of electricity per year, 130 gallons of fuel oil, and 10 cords of wood, which is the equivalent roughly of 2,000 therms of natural gas. This makes for an extremely high energy intensity compared to the average home in New England, around 96 compared to 47 kilobtu per square foot. But if you consider wood combustion a carbon neutral cycle, you get something that looks a little bit more like this. A energy intensity of only 19 kilobtu per square foot, which is much less than the average home in New England. And I'm comfortable saying that this wood use is carbon neutral because we get all of our 10 cords of wood that we use per year from our own land. We have around 70 acres, and 60 of those are effectively used as a woodlot. And in New York State, to sustainably harvest wood, you can get around 1/4 to 1/2 cord per acre per year. And this comes to around 15 to 30 cords over our 60 acres. So at our current usage of 10 cords per year, we're harvesting at a sustainable rate. Thank you.